The broadcast is now starting. All attendees are in listen-only mode.
Hi, I'm Bruce Barsenal, and I will be your moderator and webinar organizer today. Before we start, let's take a moment to ensure that everyone is ready and familiar with the webinar control panel. First, you should have a control panel on the right side of your screen. You can minimize this panel by clicking on the orange arrow button in the upper left corner. You may expand the panel by clicking the same button. Secondly, you have the ability to submit questions using the chat pane located near the bottom of the control panel. We will be answering a few questions during the webinar. However, if we are unable to answer your question during the webinar, someone will follow up with you by email afterwards. For those of you registered and logged into the live webinar, you can download a copy of the slide deck now. It is located in the handout section of the chat pane, just above the questions area. Feel free to download the slide deck now so you can refer to it later. With that, let's get started. Today's presenter is Alexia Kouros, Test Engineer 2 here at WESTPAK, a third-party product and package test laboratory with facilities in San Diego and San Jose, California. Alexia began her career here in 2014 as a test engineering intern. Her ability to conduct testing and interact professionally with clients utilizing her unique style was quickly noticed. Upon graduating from San Jose State 2 years later with a bachelor's in packaging engineering, Alexia joined WESTPAK full-time. She has performed testing on medical device, pharmaceutical packaging for dozens of life science clients. Her test engineering skill set is rapidly expanding into product reliability testing. She is on the favorite engineer shortlist for many of WESTPAK's clients, and many of whom are listening to today's webinar. Alexia enjoys world travel and family time whenever she can get away from the test lab. And with that said, Alexia, the audience awaits. Take it away.
All right, thank you, Bruce, and thank you to everyone who's joining us today. I'm excited to present hopefully some valuable tips and information on something I have the opportunity of doing on a day-to-day. So just an overview of what we're going to cover. We're going to do a review of the ASTM D4169 standard. We'll also go over ISTA 2 and 3 test series. We'll also cover some common failures and ways to prevent those. We'll go through some pros and cons of each test standard, and lastly, we'll open it up to questions. So first off, I wanted to show you all this flow chart and where package testing comes into play. Let's say one of your colleagues comes up to you with the idea for a product they'd like to bring to market. After completing the initial stages of building and testing their product, they will begin to create a package design. Following this comes sterilization, then package testing. Once distribution testing is complete, shelf life studies are done to validate the device functionality. It's then up to the FDA to approve and release the product to the market. So you may ask yourself, what is the purpose of testing? Why validate? So we can all agree that it is a requirement by the FDA, but it is also helpful in identifying the package design improvements through the distribution simulation. We want to ensure your product or device is safely distributed to the end user. So how can we test? Let's have a look. The first standard we'll be covering is ASTM D4169. So before we get into the actual test inputs, there are a few things we have to determine beforehand. One of those being we have to define our shipping unit. So a single parcel shipment will go through manual distribution simulation, whereas a palletized load would be mechanically handled. The shipping unit will determine the appropriate distribution cycle and test inputs to use. Next, we'll have to establish the assurance level. Assurance level is just a level of intensity based on its probability of occurring in the distribution cycle. Level 1 is a high level of test intensity, whereas level 3 is a low level. You might ask, where does assurance level play a part in my distribution test? The variables that it impacts are the drop heights, the test durations, compression values, as well as the vibration intensities. Next, it's important to establish your acceptance criteria. This should always be determined before you begin testing. It's your overall objective, what you desire the conditions of the product or the package once it's received. ASTM outlines 3 criteria. So 1, the product is damage-free, 2, the package is intact, or 3, both the product is damage-free and the package is intact. So next we're just going to have to determine our distribution cycle. The distribution cycle is basically just a sequence of test inputs that are used to simulate the hazard elements that are expected to happen during the distribution environment. This could help in determining things like vibration profiles. Are we going to use an aircraft vibration, a truck vibration, rail? For compression, are we going to be warehousing our units, or are they just going to be stacked in a truck? These are all things to consider when we determine the test sequence. Next, we'll have to determine the test orientation. So in the standard, ASTM suggests testing to the most stable. On the left here, I have a picture of probably the intended shipping orientation by the distributor, and on the right we have the most stable. So this is the orientation that will go through the test sequence. Here I have outlined 2 of the most common distribution cycle requests we see here at WESTPAK, DC3 and DC13. DC3 is intended for single packages and goes through a truck vibration profile. DC13, on the other hand, is for packages weighing up to 150 pounds and will be run with the air and motor freight vibration. Low pressure is also included in this distribution cycle. Today we're going to focus on distribution cycle 13. The test sequence starts off with 1, initial manual handling or drop testing, 2, vehicle stacking, also known as compression testing, 3, we'll go into loose load vibration. After loose load, we'll follow up with low pressure and then get into vehicle vibration, concentrated impacts, and finish off with final manual handling. All right, so the first test input we're going to look over is initial manual handling or drop testing. So the 2 variables that are taken into consideration when determining the drop height are the weight as well as the assurance level. So a package weighing anywhere between 0 to 20 pounds will be dropped at 24 inches when tested to assurance level 1. As you can see, as we go up in weight, the drop heights decrease. You can also see a drastic difference between assurance level 1 drop heights and assurance level 3. Below, we also have the impact orientations. As I mentioned earlier, determining the box orientation prior to testing is important because ASTM 4169 outlines the drop orientations as followed: top, adjacent bottom edges, opposite bottom corners, and the base. Next, we'll take a look at vehicle stacking or compression testing. Here we have the top load calculation outlined in D4169. The calculation takes into account the box dimensions, maximum stack height, as well as the assurance level. Just like drop testing, assurance level will determine the intensity of the test input. Below, I've calculated the top load for a box at each assurance level. The top load for AL1 came out to 350 pounds of force. AL2 was 245 pounds of force, and AL3 was 175. A lot of the times I have clients that come to me and ask, which assurance level do I test to? I always recommend testing to assurance level 1 because regardless if your package fails or if it doesn't meet the desired top load, you'll be able to still get valuable data and be able to see at which point your package reaches its max load. This could also be helpful in your 510K submission, a way to justify in your distribution environment. My package will never see the AL1 weight requirement. However, it did come 100 pounds short, which still is above and beyond what it'll ever see. So that's why I would always recommend testing to assurance level 1. After vehicle stacking, we'll go to loose load vibration. So the purpose of this test is to look at the performance of the shipper, both in terms of the strength and protection it provides its internal components when it goes through the distribution simulation. There are 2 methods. So we have A1, which is repetitive shocks in a vertical motion, and A2, which is repetitive shocks in a rotary motion. Assurance level determines the test duration or dwell time. Next, we have low pressure or high altitude testing. This test input is specific to distribution cycle 13 and is for packages that would be sensitive to low pressure environments. The test is conducted at 14,000 feet or 446 torr, and typically if your primary package is porous, it can be omitted from this test input. Once low pressure is completed, we'll move forward to vehicle vibration. First, we'll start off with the truck profile, which goes through a low, medium, high sequence. The total test profiles run for 1 hour and split up between the 3 shipping axes. Following the truck profile, we'll also run the air simulation vibration for 2 hours split between the 3 axes. Next, we have concentrated impacts. This test is only applicable to lightweight, single-wall corrugate shipping containers. Boxes identified with or above a burst strength of 275 psi or 44 ECT do not have to be subjected to this test input. For this test, a 4-pound mass falls at a distance of 32 inches onto the package. To wrap up DC13, we have final manual handling. So just like initial drops, we have the identified impact orientations from the standard. So we start off with the vertical edge, adjacent side faces, 1 top corner, 1 adjacent top edge, and for the last drop, we'll have to double the drop height and drop it at its base.
Alexia, thank you for all the information on ASTM. Let's take a few minutes to answer questions from the audience. Alexia, somebody from the audience wants to know what is considered the failure mode for compression. Alexia, what is considered the failure mode for compression?
So a typical failure mode for compression is outlined in the substandard D642. It states that a corrugate box with a 10% yield deflection or a deformation of 3/4 of an inch would be considered a failure.
And another question from the audience, is there a way to justify using assurance level 2?
So it all really depends on the value of the product or the importance of the sterility. If the sterility is not as important, an individual case has to be made to the FDA examiners, and they have to be convinced that the testing was done sufficiently and to a high level.
And finally, is there an option for stacked vibration?
So yes, so the distribution cycle that we just went over, DC13, calls out vehicle stacking and vibration to be conducted separately. There's other specified distribution cycles that allow to call out stacked vibration, like DC3 that we touched on very quickly. There's also a distribution cycle, DC2, where you can customize your profile.
That's it for the questions. Let's go resume the presentation.
The next we'll transition to the ISTA 2 and 3 test series. So the ISTA 2 series is a partial simulation test, and it includes test inputs that are very similar to the ISTA 3 series that we'll cover later on. First, we're going to be covering ISTA 2A, which consists of compression testing, initial vibration, shocks, also known as drops, as well as final vibration. Just like the ASTM standard we just covered, it's important to determine the test orientation before we begin. So ISTA 2A identifies the base orientation of a corrugate shipper as seen in the diagram here. You can see that the diagram points out the manufacturer's edge, and the edges, corners, and faces are all identified. So the first test input we're going to cover is compression testing. There are 2 compression equations for the ISTA 2A standard. The first one we're going to look at is the apply and release equation. So the variables we have to consider for this equation include the weight of the package, the number of packaged products in a stack height, F compensating factor, so if the package will be warehoused or not, as well as the 1.4 compensating factor for time. The alternative equation that we can use for ISTA 2A compression testing is the apply and hold equation. So the variables here include the weight of the package, again, the number of packaged products in a stack height, and the compensating factor. So the compression example I'm going to show you all today is using the apply and release equation. So if we have a box with the dimensions of 12 by 12 by 6 inches with a weight of 15 that we know will not be warehoused, the following variables will be indicated. As you can see, I've calculated the compression value for ISTA2A at 588 pounds of force. For the same box, the AL1 ASTM calculation came out to 350 pounds of force. The main difference between these two calculations is that ISTA2A considers the weight of the package as a variable, whereas ASTM does not. So next we have initial vibration. There are two methods for this. We can either do fixed displacement vibration or random vibration. So fixed vibration is very similar to the rotary loose lid test input that we covered earlier. We can compute the test duration by determining the cycles per minute or frequency in which the box reaches a 1-inch peak-to-peak movement. For instance, a box that moves at 240 cycles per minute will be run for a total duration of 60 minutes. Once 50% of the test duration is complete, the box is rotated 90 degrees to the remaining duration. So in contrast, we have the random vibration profile, which is run on our vertical vibration tables. ISTA2A outlines a profile that I have here below, and it is a frequency of 1 to 200 Hertz with an overall GRMS of 1.15. Next up, we have shock testing. So the drop heights here are categorized by the weight, and the package is dropped in 10 different orientations. The table below shows a comparison with the ISTA drops that we had a look at earlier. So you can see ASTM for AL1, a package under 20 pounds is going to be dropped at 24 inches, whereas the ISTA2A drops for that package would be 38 inches. Something else to note, remember the specified box orientations we covered? This is also helpful in pinpointing damaged product after testing because the orientations are traceable. Wrapping up the ISTA2A test sequence is final vibration. It's the same intensity as the initial profile as well as the same duration. This brings us to the end of the ISTA2A test plan. Now we'll take a quick look at the ISTA3A. ISTA3A is a general simulation performance test that was initially developed in line with UPS as a pre-shipment certification. So I'm briefly going to be going over this test sequence because it is so similar to the 2A, and if you do have questions at the end, please bring them up. I'd be happy to answer. So the package type that we're going to be looking at is a standard parcel, and this is identified in one of the first few pages of the standard. So the test sequence is going to start out with initial shock, vibration with top load, vibration without top load, as well as final shock. First, with initial shock or drop testing, it's very similar to the 2A. So you have the package orientation identified. You can see all the faces, edges, as well as the corners. And in the standard, it calls out specific edges, corners, and faces that are going to be dropped. We start with a drop height of 18 inches for the first 7 drops. Then on the 8th drop, we move up to 36 inches in the phase 3 orientation, and then back down to 18 inches for phase 3 again. Next, we'll run vibration with and without top load. So unlike ISTA2A and ASTM D4169, where we run compression and vibration separately, for ISTA3A, we'll be running these two in conjunction with each other. I have an example here for a box with the same dimensions as our previous examples. So you can see for phase 3, 4, and 6 down while running vibration, it'll have a 50-pound top load. Phase 3 will run for 60 minutes with the over-the-roads profile, as well as phase 4 and 6 for 30 minutes. Once vibration with top load is complete, we'll go over and run 30 minutes phase 3 down in the pickup and delivery profile. Last, we have final shock or drop testing. So this again is very similar to the ISTA2A and ASTM D4169, where we have a specified drop height and orientation. The main difference for ISTA3A is that very final drop 17, we have an phase 3 impact on a hazard. So this is where the test specimen has to strike the hazard midpoint across the longest dimension of the face, parallel to the shortest dimension of the face being impacted. Now we're going to have a look at some failures. Here are some photos of damaged boxes as a result of drop testing. So you can see in some of these photos, there are shippers that aren't intact and they're opening at their box joints. There's exposed product, and we also have indication of tape failure as well as some denting. So some simple solutions to avoid these sorts of damages that we see in the distribution environment. We could go ahead and change the box style, so we could go from a regular slotted container, an RSC, to a full overlap container, an FOL. We could also increase the board strength. We could change the taping styles, so we could go from a single strip on the top to potentially an H style taping. We could go from a single wall to a double wall corrugate. Or we could also, another alternative is to use corrugate inserts. Now I know most of these damages from drop testing are cosmetic, so it may be beneficial to just not consider changing any of your shipper design because the product isn't damaged. Next, we have some photos of packages that were tested using vibration with top load and compression. You can see that both these boxes begin to yield, causing external shipper damage. So for this test, you can see the picture on the left. During stack vibration, the walls are beginning to burst open, and there could be some potential internal damage. For this specific client, they had an overpack for their shipper, and there was about 3 inches of headspace. This didn't leave any support for the top load, which caused significant shipper damage. So some simple solutions for compression testing could be, one, changing the box style like we mentioned earlier. We could go from an RSC to an FOL or a bliss box. We can also increase the board strength. We also have the option of going from a single wall to a double wall corrugate. Another easy solution would be using corrugate inserts. And then it's also important to make sure that when the package is tested in its most stable orientation, that the flutes are vertical. This will support the top load a lot better than it would be if they weren't in the vertical orientation. Some other simple solutions for compression testing could be reducing the headspace in your shipper. So just like the stack vibration failures we went over, making sure that the top of the product is in contact or close to contact to the top of the box. Some of you may ask, should my device be load supporting? I definitely think it's beneficial to consider load sharing. You may come up with better compression results. And last, potentially changing the tape style on your box could help in also getting better compression results. So this is something we see on occasion with concentrated impacts. You can see that the mass went right through the FedEx box I have here, and depending on where the product is housed could depend on how severe the damage to the product would be. So if you are seeing failures for concentrated impacts, there's some really easy solutions. So like I mentioned earlier, the test input is omitted for boxes that are greater than or equal to 275 PSI or 44 ECT. It's also omitted if the corrugate is double wall. So maybe going from a single wall corrugate and switching over to double could be beneficial. And again, the easier solution would be using those corrugate inserts as a buffer. At the internal components of the packages, we often see damage to the primary packages. Potential cracking of trays or punctures of the pouches could be a result of distribution testing. It's important to look at how the device is housed in the primary package to pinpoint how the damage occurred. Here we have a picture of some scuffing that occurred from vibration testing. You can see that the device card is holding everything in place, yet causing the punctures in the poly material. The picture on the right is another device that has a significant amount of extra material, allowing the device card to shift and move and cause damage to the pouch material. All of the excess pouch material and pouch folding could result in punctures and compromise the sterile barrier. Additional failures can be found in the seals. It's important to establish your optimum sealing parameters during the package design phase. Stresses from the distribution environment like drops, loose load, vibration could cause the movement of your device in your primary package, causing stress to the seals. Now you're probably asking yourself, which standard do I use, ASTM or ISTA? I've listed some advantages and disadvantages. First, we'll start off with ISTA advantages. For a quick test turnaround, ISTA 2A will provide valuable package performance feedback. For drop testing, ISTA 2A also calls out drop orientations based off the specified box orientations. This can give better traceability if any internal damage is found after testing. And something I didn't talk about today, but I'd like to touch on is conditioning. ISTA and ASTM both have conditioning parameters outlined in the standards. However, ISTA 2A requires conditioning to be done, unlike ASTM. Some disadvantages with ASTM could also be the specified test orientation being the most stable. This could be conflicting to the intended shipping orientation. If we look at the drop orientations for ISTA 2A, a majority of the drops are done on faces as opposed to edges and corners. If you think about a real-world scenario, drops on a package's face are not as likely to occur. Another disadvantage with both ISTA 2A and 3A are that the test orientations identified in the standard could conflict with the intended shipping orientation. Also, with ISTA 2A, there's no way to test for high altitudes or low pressure. As far as ASTM advantages, ASTM allows variability or customized tense intensities, so the 3 assurance levels that we covered today. ASTM also takes into account materials. So for low pressure testing and concentrated impact, those can be omitted depending on your package materials. So the takeaway for today's webinar, I know we've bounced back and forth between the ASTM, the ISTA standards, the failures. We've also looked at advantages and disadvantages, but I just want to reiterate how important it is that the more accurately you replicate your distribution environment, the more valuable your results will be. It's really important to remember that, no matter if you have failures, that could be more advantageous than consistently passing tests, because if you do find these failures or flaws in your package design, you're able to pick them up in the validation process as opposed to when you're actually distributing them and they're out in the real world. So with that said, you should determine the best way to test and be able to choose, which standard is more appropriate for your distribution environment. In case you wanted to have a look at any of the calculators I referenced today, we have them on our WESTPAK website. In addition to the vehicle stacking and stack vibration with top load calculators, we have accelerated aging and sample size. If you do need to reference any of the test protocols we went over today, you can definitely find them on the ASTM and ISTA website. And with that said, that's a wrap, everybody. I hope you enjoy the rest of your day. And if you have any questions, please let us know. And I'll personally get back to you in an email if we don't get through them in this webinar. So thank you.
Alexia, thank you for this fine presentation. You covered a lot of material and gave us a lot of useful information. This is our last break for questions. Let's see what questions have come in from the audience. Alexia, someone from the audience wants to know, does ISTA 3A require conditioning?
So atmospheric preconditioning at ambient temperature is required for ISTA 3A. However, atmospheric conditioning is optional. As far as ISTA 2A, both the atmospheric preconditioning, again, the ambient profile, and conditioning is required.
And Michael asked, our pouches are constantly seeing punctures, tears after distribution testing. Any advice?
Okay, Michael, so I would suggest evaluating the pouches and looking at how they're housed in the shipper would probably be the first step. Whether the failures are coming from vibration, drops, compression, or any other stresses from the distribution environment, it's important to look at the product to pouch or tray to product to tray contact. It could be as simple as changing something like the folding style of the excess material, or adding a device card to prevent the device from moving around during the distribution simulation, causing those tears and punctures. Just going back to those slides that I went over earlier, just looking at all those different variables, it could be a simple solution. You could change materials, just looking at all those components.
And Milan would like to know, can you explain why assurance level 1 is always recommended?
So So as I mentioned, assurance level 1 is the most severe. So testing to assurance level 1 should give you the most confidence in your results.
And Seward would like to know, using distribution cycle 13, which H value do you recommend, 54 inches or 108 inches, and why?
Okay, so the standard, it has a note that states when the H value is not defined, or also known as the maximum stack height, you use 108 inches. It's only reduced to 54 inches if the package, I believe, is under 30 pounds and 2 cubic feet or less in size.
If you missed anything or would like to listen to this webinar again, please go to WESTPAK's website at westpak.com. Under the Resources Webinar tab, the webinar materials will be uploaded within the next couple of days. Please submit all test questions and quote requests to WESTPAK using the Contact Us link here or tab on our website, or feel free to call us. We will be sending you a short survey within a few minutes. We highly value your comments regarding today's webinar. Please take a moment to give us your input. You'll also have an opportunity to ask questions and suggest future webinar topics. Please contact us with any test questions, need for information, or when you're ready for a test quotation. Thank you all for attending. I am Bruce Barsenol. Make it a great day.